Alright, good evening ladies and gentlemen, my name is Wang Yen, and as you can probably see, I'm a firearm weeb. But first, I'd like to send my shoutouts to Ray, to Laurie for making this happen, and especially James, like, the penguin, the one and only penguin. I like this place. Now, let's get started. My topic is Get Rich in Isekai, a firearm nerd's perspective. Okay, all of a sudden, we are thrown into Isekai. Well, we're lizardmen, like weavers are all over this place, but we are empty-handed. We need something to protect ourselves and presumably, well, make some money, have a good second life. So, how do we do it? As a firearm nerd, my perspective is that we could be recreating this kind of modern firearms into this isekai and then register some patents, undercut the isekai version of Browning, the novel, all the greatest minds, so we can be rich. Well, I wouldn't be bothered doing something like a silkback musket, black powder, that sort of thing, because simply, like if you have that sort of antique into an isekai versus a dragon, you are gonna die. So, the first thing that comes to my mind is this: a timeless piece of engineering marvel, the AK, the automat Kalashnikov, if my pronunciation is right. But like, how do we replicate? So, we need to scale down the problem size. Scale it down to the basic building blocks of it. About the firing cycle, it discharges, recharges, and extracts the old bullet, and now pushes the new bullet into the chamber and targets the very thing it shoots. And the propellant is a thing that is in the bullet and burns, combustions, producing the gas that pushes the bullet out. And pay extra attention, it's not a step-by-step guide, so if you want to do the thing really in the isekai, if you're obsessed with that. If you really want to do this into an isekai, you have to do your own homework. But now, let's back to the AK. First, if you say AK, you're probably going to be scared out. Oh, it's too complicated. Even every people say it's like, it's simple, it's robust. Well, 9 out of 10 people would bring that thing to Mars, but it looks still, well, to us naive to firearms, it's too complicated. So first, let's remove everything that is not needed in a proper fire cycle. Boom, and we got this. Of course, you cannot hold it and fire because we don't have a stock, we don't have the dust cover, and technically we don't need the sight because like, well, it's the footage is borrowed from Tarkov and I cannot remove the sight, but that is a core component we got. And probably, if we remove the magazine, this is what we got. The receiver, the trigger assembly, and the bolt carrier / recoil spring, whatever, and a barrel and a gas piston. That's it.
Could you point some of these things out that you're talking about?
Okay. This one's the receiver that holds everything. This one is like the bolt carrier, bolt assembly. This is the trigger assembly. It's deep inside. It's down there, and this is our barrel, and the thing up to our barrel is the like recoil the gas piston, and this is a recoil spring. That is all you need, but that still looks a bit more complicated, right? So do you have another way? Okay, let's look at this. The Mosin. The Mosin is a firearm designed in the late 1890s, and it looks, well, more or less the same, but deep down it's more different. If we remove all the unnecessary parts to perform a fire cycle, this time including the barrel, we got this. The trigger assembly, this one, the firing pin, this sort of thing, and the bolt carrier, the charging handle, whatever, and the actual bolt itself that holds the bullet. This one, that's a core opponent that looks much more simpler, and if you have any engineering background, you'll notice this thing is much more easy to manufacture than the AK. So we keep this core component in mind. We switch to a more fancy version, SV98. It got a floating barrel, the polymer chassis, all that sort of fanciness, but deep down, it is still the very same principle, the very old trick. So now, we got a basic idea of how it looks. Let's go to something more intuitive. A Mosin actually performing a fire cycle. Okay, let's see the video. First, pay attention to my cursor. Pull the trigger, the pin is gonna hit the bullet, it's gonna fire, and then it's gonna extract new bullet into the chamber. But that is playing a bit too fast, and let us say again. Okay, pull the trigger, the pin is released. What the trigger does is a hook. It unleashes if you release the trigger, it unleashes the hook, and the pin is free. It hits the primer of the bullet, and then it is discharged. Now, after the whole thing, we're gonna rotate it. Why do we rotate it? Because we need to lock the bullet into the chamber, because the force is gonna go both ways. If we don't lock it into the chamber, the casing will gonna go like this, and the bullet's gonna go like this. It's gonna be jammed in the barrel. And now I want to extract it. Look at this one. This very little piece, and with the casing, the bullet casing, that creates a sort of leverage and pushes the bullet out of the chamber, and then pushes another round inside. If we see it, it's moving. And now let's see it again. But this time we're showing the rotating bolt mechanism. Oh, sorry. But this time we're showing the rotating bolt mechanism. You can see there are two notches. That's the very mechanism that holds the whole thing into the place. We basically need a loose copy of that, so we just need to understand the principle. And then, boom, new chamber loaded. And then, this time, not shooting, just doing the whole thing. Boom. Now, we have an understanding of this. Let's head back to the AK. The AK has an auto-loading mechanism. What is auto-loading mechanism? Like, if we pull the trigger, we pull the bolt and then rotate it after over so many times, we're gonna say, oh man, this is a pain in the ass. Can we let the mechanics do it itself? And the answer is, it could, because the projectile is pushed by the combustion of its propellants. We can use the gas generated in the process, pushing the bolt back. Because of the bolt and the bolt carrier is pushed back, we need something, a recoil spring, to push it backwards back to its original place. And how do you do the lock-unlock rotating mechanism? You use a slope. More to that later. There's the supplementary materials. But let us see. Oh, sorry. Let us see how it works. Oops. Pull the trigger. Same old thing, but this time it's like the hammer. The trigger is like releasing the hammer hits the pin does the whole thing. Same old trick. So now, doesn't that look much simpler? You can attach a different grip, different stock, different shape of dust cover, whatever, but deep down, if you understand this, you are getting the essence. Now, I said we're going to be making something that is a proper modern rifle, so it cannot be smoothbore, because we need the bullet to rotate in the chamber, in the barrel, and then it creates what is called angular momentum, so that it can stabilize itself when it flies out of it. How do we do it? Using this, a wooden Iowa rifling bench. Rifling was invented in German by some random German engineers in Nuremberg back in 50-40 something. So, yeah. Back in 50-40 something. You can see this twist thing of the wood. That is how we create what we call a twist. What is a twist? It's how many inches you move for your barrel for the bullet in your barrel to rotate a whole pie, a whole circle. If one circle per 10 inch, we can call it has a twist of 1 to 10. And you got more than one, you got more than one this kind of rifling. You usually create 6 to 8, perhaps more. You take several runs, but as you can see, it's pretty simple. You can do it with any carpenter, and then you need some cutting heads. There are different types of cutting heads. The button, the single point cutting head, and the broaches. Broaches is the next circle is always bigger than the previous circle, so it cuts the whole thing gradually. Now, we got this inside. We know how to make the whole thing fire and recycle, and now we know how to make a proper barrel. But, okay, sorry. Let's see how it works with the footage. Basically, that's a very simple mechanism. This is a modern replica, but you basically need a placeholder, and then you move it. Boom, it's gonna move forwards. And thus, after several rounds, a single rifling is created. It definitely takes multiple rounds. And now, let's take to the cartridges. What does it fire? Let's take the 5.77 Martini Henry rifle as an example. You know, like cartridges in our mind is more or less like this, right? But in the early days, when the machining techniques are not that advanced, they're using this kind of 1872. How do they do it? First, they got a brass casing, and then they wrap some fine metal sheets on it, creating this kind of like sketchy, floppy walls, and then they toss them the black powder, and then like some sketchy made lead projectile into it with some oil paper wrapped. Depending on the technology you have, you might choose from this to this. Now, we got the earliest version, but as the time goes, you can see it's definitely almost pure like manual. How do you make this consistent? How do you like, when the demands goes up, how do you like create many of the casing consistently? Now, introducing the brass drawing process. Let's use the Lebel M8086 as an example. The very cartridge it uses, like, is the first rifle adopted by our government using a modern cartridge. What is a modern cartridge? More to that later. But first, let's come to the casing. It basically uses a single brass sheet, and then you use a mold, apply tons of pressure into it, gradually several runs into this. That's looking more familiar, right? But why is that modern? That's modern because not only because of its casing, the inside, the propellant, and the shape of its projectile are also modern. It also has a primer. But now let's talk about the shape of the projectile itself, the bullet itself. As the early days, it's more of like pure lead and then into some wax mold. It's okay. As the thing goes, we're applying metal jackets, copper jackets for it to like better weather resistance ability and like more consistent performance. And then like engineers discovered that if we use a pointed tip, the ballistics coefficient and its after effect is going to be even better. And several years later, into number NATO standard issue 223 green tip and 8055 has steel penetrator, lead plug, and the copper jacket. It looks pretty complicated. But then again, deep down, if you're like very limited on your technician methods, you can just go to the simple lead. That'll do. Also, the 855A1's improved penetration, so to speak. The arrowhead steel core, and it doesn't have the lead. Why? And due to some like environmental regulations. It's so interesting that this kind of thing still applies to militaries. But after we talked about the thing, now let's talk about the propellant, the thing that powers the whole bullet. Well, let's see the 303 British. And we can see a transition because it's very old. It was like invented in 1888. Well, but it was still out of date since day one. Why? Because the French did the better thing 2 years before them. They were using black powder as the very first place, and then the British discovered, oh God, the French are using something better. We must have one as well. Then they applied the cordite. Well, some early smokeless powder, and then into this more fancy, more modernized like smokeless powder pellets. But deep down inside, like the smokeless and the smoked are very different. Why? Why black powder is a no-go? First, it gets wet. If it gets wet, it doesn't fire. Very simple. And second, it's inconsistent because the oxygen balancing is not good. You have the charcoal as the fuel and have the charcoal as charcoal as fuel, sulfur and potassium nitrate as this kind of oxidizer, whatever. The single ingredient of these three, if you separate them, it does not combustile on itself. But modern propellants, they do. Also, what is called corrosion. After they burn, something is left in the barrel. And if you're using this kind of like auto-loading, especially during the United States Civil War, this auto-loading lever rifle, boom, you shoot 10 rounds, 14 rounds, and the barrel gets really dirty. You got to clean it very oftenly. Also, the poor performance. Why? Because like to create a more powerful round, we need a bigger chamber pressure. So the the basic ingredients for smokeless powder are first NC, nitrocellulose, and G, nitroglycerin, and these two are two potential candidates because if you're in an isekai, I don't know what you can make, and these two, like, if applied properly, and it might do, I don't know, it takes failures and experiments, but it's easy to make, easy to synthesize. Basically, the nitrocellulose, the gum cotton, it's like high polymer, so you mix nitric acid and sulfuric acid by volume in 1:2. Nitric acid is 68%. If you have the smoking nitric acid, it's going to be better, but that's highly like unstable. In order to stabilize it, you need to solve it into ether or alcohol, like creating those kind of like less aggressive thing for storage. Same thing happens to nitroglycerin. Nobel's little brother died in the stabilization experiment of nitroglycerin. So you know how important that is. And yes, that is for the thing. Especially like if you're doing those kind of energetic materials, be extremely cautious on your temperature control. Extremely cautious. Why? Because I've had lessons. Well, that's a whole different story, but now let's say how cordite burns. It looks like spaghetti. You probably think it's a spaghetti, but it burns. This is a cordite after, I don't know, dozens of years, decades of storage. It still burns like this. Its original formula is 98% of nitro Ng, 37% of Nc, and they're using petroleum jelly as this kind of the gluing ingredient. Everything's solved into acetone to like further dry it out to make it form its shape. And this thing, invented by the Frederick Abel and James Dewar, they had a lawsuit for years with Alfred Nobel. Why? Alfred Nobel invented something that is similar, which is called ballisticide. The ballisticide is slightly different, but its ingredients are 45, but he doesn't get the petroleum jelly, he got 10% of camphor, a natural product that you can find in kusunoki.
You mean the tree?
Yeah, the tree.
Okay.
It means a tree. And we know, because it has a very good smell, we know it vaporizes. So during long terms of stores, if the camphor goes away, that thing is going to be extremely lethal, extremely dangerous, because like the lowered sensitivity is now restored back. Now, into the primer. We're talking about, if you're paying those attention to the pictures, we're talking about the things in the main chamber of the bullet, but what is used to ignite it? To ignite it, we need to use something that is more sensitive, but not that sensitive. So, what is a Mordant primer? A Mordant primer is like a copper cup and an anvil, a metal sheet, and it assembles like this, and then the firing pin hits here, it hits here, and it's going to squeeze with each other, creating a very condensed energy. And that condensed energy must exceed is like the impact sensitivity of the primer igniter compound, and then it's going to go off, it's going to like ignite the main propellant, and the whole thing is going to go off. You might ask, can we just like don't have this kind of thing? No, because like if we use the main propellant into something that is of similar sensitivity, well, it might go off more easily. And this is a primer, it's in basically centrified in the center of the bottom. So like usually you don't drop it while hitting that part of place particularly, so it's safer. And the primer compound, first, around 40% of barium nitrate, I'm sorry for that, and 40% of lead stephanite. That is synthesized by what is called a metathesis, basically high school chemistry. Stephanite magnesium plus like the acetic acid lead, and then you got the whole thing. Tetrazane, it's another thing, but in an isekai, if you're having difficulty purchasing it, it's probably fine. Just add some aluminum powder, more aluminum powder, you know. And another like substitute to the LS is lead azide. What is azide? Triple nitrogen inside. And to create that, to like do that in the production level, there is basically a diagram. And what else doesn't matter? What matters is this, the dextrin. Why do we use dextrin? Because both LA and LS are originally on its natural state. Very sensitive, so we need to tame the beast. It literally goes off if you like smash it onto the ground. And in natural state, leadazide is like this kind of needle-shaped, what is that called? Crystal, yeah. So in order that the crystal is smaller, into more round-shaped, we need to add dextrin and other things. Let's say carboxymethyl cellulose, that sort of thing. Basically, the ingredients you can find in modern-day food and beverages. So it's a pretty simple trick, but pretty important. You can see the metal structure, and now we have a basic idea of how you do the whole thing. This is like something just for a teaser to blow your mind up. And now let's into the Q&A section. Thank you. I'm going over time.
All right, thank you very much. The floor is open for questions. I think there probably is a lot of questions that might be going around here.
You mentioned a lot of old. Oh, sorry.
Yeah.
No, Laurie.
You mentioned a lot of old tech.
Yeah.
You know, kind of 100-year-old rifles.
Exactly.
As a firearms nerd, what kind of new tech, like digital guns or something, what new tech gets you excited?
Well, the basic principle of a firearm remains more or less the same, and like the modern igniters, whatever, they're just like more stable, like something like that. The advances in small firearms, particularly small firearms, are more with those kind of accessories and the receiver design and those kind of optics. You know, thermal hybrids, that sort of thing. But deep down, the inside remains much more or less the same.
Is there anything that's on the horizon that's exciting for you?
Well, technically, for the core principle, perhaps not, because like for the energetic material, the propellant, you know, countless people have been developing during the past 3 decades, trying to develop something that is newer. But the new things are either poor in performance or hard to synthesize, because like older things, the structure is pretty simple and they're pretty mature. But like, you know, if a new thing that is like 10% better, but it takes significantly more steps, the route is so long, so to speak, how do you apply it into an industry level? If it works fine, it works fine, something like that.
Yeah, thank you.
If it's not broke, go fix it.
Yeah.
You had a question?
Oh yeah.
Please?
I mean, you said that like you kind of had some experience in stabilizing some of the compounds that like explode for the propellant. So
No,
did you ever
no,
try to
that
make
is-
anything about, like, did you ever try to make any of them in the lab?
Well, that's a sensitive
You don't
question.
have to answer that.
These are the footages that I borrowed from other people, but that illustrates the whole thing. But first, like, long before I came to Japan, I did some of the things, like I was an amateur rocket maker. So a lot of those like potassium nitrate, glucose thing. And then at the age of 15, I locked myself into my balcony making PTN. Yes. And
Like every 15-year-old does.
oh yeah, thank you. And then I like flushed into flush it, basically, because how am I supposed to get rid of it?
I guess flushing it is the way.
Into the toilet, yeah, it's pretty simple, man. Yeah, please.
You mentioned how pointed slug has better ballistics than a rounded slug. Do you know why?
Well, because like after some actual war experience, the round shaped, it's pretty stabilized even after it enters a soft tissue, namely body. So like the Japanese type 38, whatever, that sort of thing, it goes into the body, it goes out because it's like round shaped. There's no collateral, there's no shattering, that sort of thing. So that is basically to make the whole firearm be more lethal. But the full metal jacket is not the most lethal form factor. The most lethal form factor is like a soft point. You know, the lead is exposed and then the copper jacket. And if it enters the body, it's going to be really nasty. You can search it on the YouTube what's called RIP ammo.
How about now?
But sorry, I just wanted to say, rather than like effectiveness in ballistics, like how like is a point it's like more accurate in its ballistics?
Well, technically, but it still depends because like better as time goes, the manufacturing precision is more better. I'm sorry for my poor grammar, but like it's pretty hard to compare a piece of old tech and this newest pieces of tech. But overall speaking, yes, newer tends to be better, and there's always a reason. Oh, Ray, please. I'm sorry.
Wait, was there something? Yeah, please.
How fast is a modern automatic rifle? And do they, like the manufacturers, do they really chase the speed of like the firing?
The rate of fire.
Yeah.
The rate of fire is like for a machine gun. Thank you, ATF. The fire cycle rate is typically 600 to 800. Why? Because if it goes too fast,
what?
RPM, rounds per minute. If it goes too fast, it's going to be uncontrollable. So technically, we can make it pretty fast. But if you cannot control it, if you cannot hit anything, it's pointless. And like during the older days, you know, bolt action versus like first generations of submachine guns, that is basically for close encounters. In close encounter, you wish your rate of fire to be the higher the better. But in those like mid-range encounters, like more than those kind of conflicts, not actually total wars, it's like if you do those kind of sprays, full auto sprays, you're running out of ammo pretty fast. You ready, please?
So you mentioned a lot of like auto-feeding cartridges.
Yeah.
And in the principles of say like revolvers.
Yeah, revolvers.
Don't eject any kind of cartridges, but like revolves the.
Yeah, revolves the chamber.
Is the principle the same, or is it more simpler in the sense?
Oh, the revolver.
They like are less likely to jam is like one thing.
Well, revolver like it don't jam, but one thing is important called timing. There's a ratchet, there's a mechanical, the correspondence of a round to the barrel because like it is not tightly attached. And if you mess it too much, the timing goes wrong, it'll still go wrong. But the major problem of a revolver rifle is like you have this kind of thing. Like if your ammo size is 6, it's okay. If it's 8, you can still manage. But if I'm about to do something like, let's say, a magazine capacity of 30, you cannot have this big of a structure, of course. That's a major advantage of like a box magazine. Also, draw magazines are great. Like draw magazines, yeah, it's big in capacity, but like a box magazine is easier to carry. The draw magazine, its shape is too weird.
Okay, James.
Sorry, Wang, you lived in the States, right?
Yeah,
How long did you live in the States for?
less than half a year.
Okay. Did you get the chance to shoot guns when you were there?
I did.
Oh, great. What was that?
Well, shabby Gen 3 Glock.
Okay, sorry, what state was it in?
Glock 17, Gen 3. Generation
State.
North Carolina.
Oh, nice. Okay, great. And then you shot a Glock.
Yeah.
Okay. At a shooting range?
Yeah, the shooting range, of course.
Okay. I'm just curious.
But I do have a hunting license. It's probably expired now, but I do have it.
In the U.S.
Yeah. So technically, I could purchase one back there, but then again, like, especially 9 mils are skyrocketing during those years. No. How about no?
Sorry, if anybody has a number.
Oh, please.
So, like, 3D printing guns
Yeah.
is a conversation that goes around, especially in the U.S. Somebody in Japan even got arrested.
Oh, yeah.
For, like, either printing it or even having schematics, and Japan has, like, very strict gun laws. But, and then you have cases all in, like, the Civil War in Myanmar of
Oh, yeah.
actually the machine guns.
Exactly.
Is that principle is the same? I don't feel like you can build like a spring with like just a plastic thing. I guess there's like other components necessary.
Yeah.
What components is suitable for a 3D printing? What can you that little like simplified diagram of a pump action section, is all of those replicable in a 3D printed
Definitely not. First, just like Glock, when Glock first came out, there was widespread concern.
What's a Glock is what?
A Glock is a polymer pistol that the majority of its body, like the chassis, so to speak, is made by plastic. People are concerned that it's going to bypass the security check. But what they don't know is the barrel, which must stand the chamber pressure, and the ignition mechanism, and the magazine, they must be metal. And it's same principle applies to 3D printed guns. If you need something that fires a 308, let's say, you must use a steel chamber. 308 is a more powerful. It's a rifle cartridge. It's more powerful, and it's pretty loud. It's so loud.
So it's not possible to literally print something out.
No, you cannot. The barrel and perhaps the firing pin, whatever. But if you're saying you want to build a pump action, then the pump spring, that sort of thing, it must be metal. You cannot create a plastic metal. It's basically creating those kind of you need the furniture of a weapon. You need CNC previously. You need good wood previously, but now we can do it in this kind of hardened plastic, and then we further simplify it. It's probably 3D print. But the core components are more or less essential to be metal. Please, sir? You got
As an extension to that question,
Uh-huh.
are you familiar with the carbon pass copies? For example, a Kalashnikov copy that was handmade.
handmade, not quite, because if you handmade it, everything's gonna be pretty sketchy, and there are plenty of people doing that, but they're mostly based in the United States, and come on, if you're in the States, you'd better buy a real replica of the Kalashnikov instead of garage making your own.
You just buy it.
Well, if you do it in the garage, it's gonna cost more than you just buy one. Literally, it's equipment.
All right. Well, that's time we have. So everybody give another round of applause.
Thank you. Cheers.